Hi, fourth grade friends. Coming to you from my classroom this time instead of my house. Hey, what I want to do today is take a look at some math together. We're going to look at page 235 in your learning packet from this week. It says Frederico's Fort on the top. And we're going to do a couple things today. But before we dive into it, I want to go over our classroom norms again. I didn't bring my paper with me, but I think by now you guys all know what our classroom norms are. We're going to have a positive attitude. We're going to be respectful of the people who are around us. We're going to keep trying even if things get tough. And finally, we're going to remember the word yet. With that in mind, let's dive into some math. So our main goal today is going to be looking at how we can create equivalent multiplication equations. And we're going to look at that by looking at question number 4. But before we do that, I want to look at question number 1, 2, and 3 real fast. And remind you all of something, is these problems are all area multiplication problems. And a lot of you have been doing a really good job with your area multiplication. I've been seeing those answers coming in. And a lot of you are doing a really good job getting those answers. But I'm noticing something is some of you are forgetting a really key step for whenever we take a measurement. And remember, area is a form of measurement. And whenever we do a measurement, we want to make sure that we include units in our answer. So for example, if we're measuring the area of something in inches, I want to make sure that my answer has inches in it. Or if I'm measuring something in feet or meters, same story. I want to make sure that I have feet or meters in my answer. Quick reminder for you guys on that. Now let's jump into question number 4. Remember, we're looking at creating multiplication equations that are equivalent to each other. And like always, there's a couple ways we can go about doing that. Now, the first example I want to show you looks like this. It's the simplest way of finding equivalent multiplication equations. I've got an equation up here. It says 9 times 30 equals 10 times 30 minus blank times 30. I want to pause. I want to actually do that again. And I want to remind you, we can read this equation, even though there aren't any words in this equation. It's all numbers. But I can use it using some different words. Try like this instead. 9 groups of 30 is the same as, remember equals can mean is the same as, 10 groups of 30 minus blank groups of 30. Or if I want to have 9 groups of 30 and I'm starting with 10 groups of 30, how many groups of 30 do I need to subtract to end at 9 groups of 30? Some of you are already yelling at your screen, Mr. Field, the answer is 1. If I have 10 groups of 30 and I take away 1 group of 30, I'll have 9 groups of 30. You're totally right, but I want to prove to you that that's correct. The cool thing about this is I can go and I can solve each of these equations and check it and make sure that those answers all make sense and work together. Let me show you. I've got 9 times 30. I know off the top of my head that's 270. I did this before I recorded. It's okay if you didn't know that. So 9 times 30 is 270. 10 groups of 30 is 300. And 1 group of 30 is, well, it's 30. And I can plug in those same equal signs and subtraction signs from before and see if this statement, because this is a mathematical statement, makes sense. 270 is the same as 300 minus 30. Well, if I have 300, I take away 30. Yeah, I'm going to have 270. So that checks out. Nice. Let's take a look at another example. This style is going to be really helpful when you're looking at a problem like letter B, 4B. And this one's a little bit more complicated. This is an example problem. It's not the same problem that you have for 4B, but it's going to be a same strategy. So my example problem is going to look like this. I got 24 groups of 16 is the same as, parenthesis, 20 groups of 10 plus 20 groups of blank plus 4 groups of 10 plus blank groups of blank. Now, some of you are going to try and start solving those equations right away, but before we do any arithmetic, before we do any solving, I want to make some observations first. I'm noticing as I'm looking at these two sides of my equal sign, that 24 times 16, or 24 groups of 16, and I'm noticing 20 times 10, 4 times 10, 20 times blank, and I'm noticing these two numbers right here, 20 and 4, well, 24 could be seen as 20 and 4. In a similar way, I'm noticing 10 and 10 in both of these equations. And I know I can think of 16 as 10 and 6. And some of you right now are going, Mr. Field, wait. All year long, you've been telling us that when we multiply and we want to break apart some numbers when we multiply, we can only break apart one number or the other number. And I'm going to tell you something that maybe is going to blow your mind a little bit, but you actually can break apart both sides. But we were working with just breaking apart one side or the other during those times. Now we're going to look at how we can break apart both numbers, because we can. Now the important thing is when I break apart both numbers in a multiplication problem like this, where I've taken 24 and I've broken that into 20 and 4, and I've taken 16 and I've broken it apart into 10, and 6, I need to make sure that I've got 4 multiplication problems. Okay, 4 multiplication problems, and that will give me my answer, and it'll be equivalent or the same as. And what I need to do is I need to make sure that I've got all 4 of these being used. So I'm going to multiply 20 by 10 and 6, and I'm going to multiply 4 by 10 and 6. So I'll write out those 4 equations we need. I need 20 times 10. I need 20 times 6. I need 4 times 10. I need 4 times 6. And as I'm looking at this, I'm noticing I've got a few of these already. 20 times 10, right here already. 4 times 10, got that right here already. Now I don't have 20 times 6 yet, but I do have a 20 times blank. So I can put a 6 in here. 20 times 6 goes right there. So I've used this equation, this equation, this equation. And I know without a doubt that this final blank times blank, that's going to be my 4 times 6. And just the way that I showed you with that previous problem, I could then go in, I could solve 24 times 16, and then 20 times 10, 20 times 6, 4 times 10, 4 times 6, add all of those together, and this side of the equation would be the same or equivalent to this side of the equation. Let's look at one other strategy real fast. And one thing I'm going to tell you is that when you're looking at 4C, I'm going to want you to think about a topic we've talked about in the past. And that topic is halves and doubles. So, for example, let's say I've got an equation 12 times 8, or 12 groups of 8. And I want that to be the same as, or equivalent as, 24 groups of blank. Well, I'm going to think about halves and doubles again. I'm already seeing 12 is half of 24, or to get to 24, I doubled 12. So if that's the case, to keep both of these sides of the equation equivalent or the same, since I doubled 12, here, I'll draw a little arrow, reminding myself we multiplied by 2. If that's the case, then I need to half 8. And so to keep this the same, half of 8, I know, is 4. And those are going to be some really nice different strategies for you to solve these equivalent multiplication equations. I'll see you later, 4th grade friends.